Here we see a close-up of the x equals 30 point of the previous graph. X is going to be diameter in centimeters, y is volume in liters. I really should have labeled those on this graph. It's a bad habit not to do that. We have the graph point at 83.7 liters volume and 30 centimeters of diameter. And again, I labeled the liters here. I should have labeled the centimeters down here, if not here. Okay, confession's over. Now, at this point, we draw the tangent line, this black line that kind of accidentally tails off here, but that's a good way to indicate that to distinguish the tangent line from the actual curve. So we have the tangent line to this point and the actual curve represented here. We see that the actual curve is going to deviate a little bit, actually not even as much as this picture shows, between x equals 30 and x equals 30.1 centimeters. That's a very small segment of the actual graph, and it's going to be very, very nearly straight. However, in order to see that there is a difference, I've exaggerated that difference a little bit here. Okay, again, the tangent line has a slope of 8.37. Now, as we go from 30 centimeters diameter to 30.1 centimeters diameter, we have a delta x of 0.1 centimeter. Now, if we have a delta x of 0.1 centimeter and a slope of 8.37 liters per centimeter, if you put units on it, then what's the rise of this green triangle going to be? Well, it should be pretty clear that the rise is going to be 8.37 liters per centimeter multiplied by the 0.1 centimeters. And that's going to give us our 0.837 liters as we calculated earlier. So that this slope calculation here, the slope triangle calculation following the tangent line, is what we really did before. This is a graphical representation of what we did. And we see down here that our delta y is represented then by slope multiplied by delta x. That's a no-brainer, since delta y over delta x equals the slope. So we multiply the slope by delta x, the 8.37 liters per centimeter, by the 0.1 centimeters, and we get 0.837 liters of difference. An approximation to what actually happens on the curve. Not exactly what happens, but a very close approximation, as long as this distance is small. And we can further state that anywhere in the immediate vicinity of the 30 centimeter diameter, the slope of this graph is going to be pretty close to the slope of this tangent line. And we could use the slope of this tangent line as an approximation to the rate at which the volume changes with respect to diameter at any point close to 30. Now, what we mean by close to and how much error is there in some of these approximations, these are topics that we take up much later in the course. They're very important questions. I hope they've occurred to you, and we will be talking a lot about those questions later.